Hello students, today we will see the next part of the particular analysis that is called as a nodal analysis. So in nodal analysis we have to use the Kirchhoff's current law, while in mesh analysis we have to use the Kirchhoff's voltage law. So here we have to use Kirchhoff's current law, that is called as KCL. Okay, so there are the different steps to apply for the nodal analysis, and after applying these steps you will get directly the results. So in mesh analysis, we have to use the steps in nodal analysis. While solving the problems, there are some few steps are there to solve the problem of the particular analysis. So in nodal analysis, the first step is what? Identify the number of nodes in the circuits. Identify the number of nodes in the circuits. So here in the particular circuit diagram we just identify the number of nodes. Okay, so here we have the voltage source, that is 10 volts, 20 ohm resistance, 15 ohm resistance, 10 ohm resistance. Here Vd equal to what? 80 volts are there. Okay, so just check it how many branches are there. This is one branch, second, third, fourth, fifth. Okay, so whenever this branch will meet together at a one point, that will form a nodes. Okay, so here it will be form a first node, and here it will be form as a second node. So first node and second node. So I will write down this one as a first node and second node. So and this will be what? Third node. So this is a ground node. So the ground node has a voltage will be what? That should be 0. Okay, then afterward, after finding out the nodes, second point is what? Assign the node voltage. Assign the node voltage for this. Okay, so for this point I have to assign the node voltage as a V of B, and for this one it will be of V of C is there. Okay, V of B and V of C is there. Okay, after applying the node voltage, the third point is what? Mark the direction of current. So the current will be always flowing from where to where, that is from plus to minus of voltage source. So after this we have to assign the direction of currents. So for this one it will be, the current is what? That should be flowing from plus to minus. So I will remark this one as a I1. Okay, so for this one I will mark this one as a I2. Okay, then again for this branch I will mark this one as a I3. Then for this branch I will mark as a I4, and here the current is flowing from where to where, that is from plus to minus. So for this I will mark this one as a I5. So there are the 5 currents are there. Here we have I1, here we have I2, then here we have I3 is there, from VB to VC I3 is there, from VC to ground I4 is there, from VC to VD I5 is there. Okay, then the fourth and most important part is apply KCL for each node. So I will explain it what is KCL, and after applying the KCL at each node we have to write down the equations. Write the equations. So we have to write down the simultaneous equations, and we have to find out the value of what? I1 and I2. Okay, so for this one we will just go for these steps. So already I will mark assign the problems, and we will just go for one by one steps. So first step is what? Identify the number of loops. Already identify the number of nodes. So two nodes are there, 1 and 2. Third node is what? That should be ground node. So for that one the voltage will be what? 0. Okay, so current I1 is, then we have to mark the direction of currents. So I1 is flowing from here, then I2 is there, I3 is there, I4 is there, and I5 is there. Okay, After that, we have to apply the KCL for each nodes. Okay, so how we have to apply? Just check it here. Apply KCL for node of VB. So here, so two nodes are there, so there will be two equations. Okay, so what is KCL? Just remember, this is a nodes. Okay, so we have to apply the KCL at this node. So two currents are entering and two currents are leaving. I1, I2 are entering and I4 and I3 are leaving. Okay, so the KCL will tell us that the algebraic sum of entering current must be equal to the algebraic sum of current leaving currents. Okay, so entering current to the node is what? I1 and I2. So I1 plus I2, that must be equal to what? I3 plus I4 is there. Okay, I3 plus I4. So two currents are entering and two currents are leaving. So these are the KCL. Okay, so we'll start from here. So for this one, apply KCL at node VB. Okay, so just check it how many currents are entering towards the VB. So here I1 is entering, then I3 and I2 are what? Leaving. So I will write down I1 entering current equal to what? Leaving current, I2 plus I3. Okay, now we will just check it what is what, how we have to write down the I1. So already we must know Ohm's law, that is V equal to what? IR is there. So I equal to what? V by R is there. Okay, so I1 is start from where? It will be start from VA. So I1 will start from VA and end at where? VB. Okay, so starting voltage is VA and ending voltage is what? VB. So I equal to what? V by R. So here VA minus VB divided by R value. So R value is what? 20 ohms. Okay, so I1, this is the I1. Okay, so I1 equal to, already we will write down VA minus VB divided by 20 equal to. Similarly, I2 is what? Starting voltage for I2 is what? It will start from VB, end at what? VD. But VD equal to what? 0. That is a ground voltage. Okay, so I2 equal to VB divided by, this value is what? I will write down 10 ohm. 10 plus, now just check it, I3. So this is I3. So I3 start from where? It will start from VB and end at what? VC. So VB minus VC divided by 15. Okay, VB minus VC divided by 15 is there. Okay, now we have to put the value of VA. VA is how much? 10 minus VB divided by 20 equal to VB by 10 plus VB minus VC divided by 15. Okay, now we have to solve this simultaneous equations. How will solve it? 15 will be divided by VB, 10 will be divided by here, and 20 is there. Okay, so for this one I will start for solving. 10 minus VB divided by 20 equal to 15 VB, 10 into 15 plus 10 VB minus 10 VC. So just solve it. After solving, again you will do the cross multiplication. So solving this, you will get 13 VB minus 4 VC equal to 300. So this is the first equation. Okay, so here we have to apply the KCL for node VB. So first equation I will write down on the top side because I have to use this afterwards. So here I will write down 13 VB minus 4 VC equal to what? 300. Okay, now we have to apply the KCL at node VC. So this node I have to apply. So for this one, the starting voltage, just check it, I3, starting means current entering towards this node is I3, while leaving will be what, I4 plus I5. Okay, so I3, just check it, it will be start from VB minus end at VC divided by 15. I4, just check it, it will start from VC end at VD. So VC by, here the value is what, 10 ohm again, 10 plus I5 start from where, just check it, VC. Okay, minus, but here again there is a minus side. So minus of minus 18 divided by I5 value is what, 10. Minus of minus VD, but VD directly I will put it 18. So minus minus is again, it will become to plus. Okay, so just do the cross multiplication. VB minus VC divided by 15 equal to 10 VC plus 10 VC plus 18 divided by 100. So just do the cross multiplication and write down the values. So here we will get the value as a VB minus 4 VC equal to 120. So this is the second equation. You just do the cross multiplication at home and solve this. You will get VB minus 4 is equal to what, 120. So here we will write down VB minus 4 VC equal to what, 120. Okay, so we have to solve this simultaneous equations. So how we will solve this simultaneous equation, just check it. So this is first and second. So what we will do, subtract second from first. Okay, so 13 VB minus 4 VC equal to 300. So we have to subtract VB minus minus, it will come plus 4 VC equal to minus 120. Okay, subtract 1 from 2. Okay, so it will cancel. You will get it what, 30 minus 13 VB minus VB. So 12 VB equal to 180. Okay, so VB equal to what, 180 divided by 12. So that come 15 volts. So here we will write down the result, VB equal to 15 volts. Okay, so on one side you will write down the VB equal to what, 15 ohm. Okay, 15 volts. Now what we will do, we will put this in equation number second. So put the value of VB, that should be 15 volts, in equation number second. So from second, so this is first, this will be what, second. First, from first and second, from second what will do, 15 minus 4 VC equal to 120. So minus 4, sorry, minus 4 VC equal to 120 minus 15. So minus 4 VC equal to 105. VC equal to minus 105 divided by 4. That should come minus 26.25 volts. So VC equal to minus 26.25 volts. So here we will get the value. But what we will do, we have to find out the value of I1, I2, I3 and I4. So first again I will write down I1 equal to, just check it, I2 equal to, I3 equal to, I4 equal to and I5 equal to. Okay, these 5 currents are find out. So I1 is start from where, just check it. Here the I1 is start from 10 to VB. So here again we will write down 10 minus VB divided by 20. I2 is what? I2 is from VB minus VD. VD is 0 divided by 10. Again I will write on I3 is what? VB minus VC divided by 15. I4 is what? I4 equal to VC minus 0. So that should be VC by 10. Okay. And I5 I have write down I5 equal to VC plus 18 divided by 10. Already we have write down. Okay. So you just put the values here. VB is the 15. So 10 minus 15 divided by 20. So here it will come 4.25 ampere I1. Okay. So I2 is VB by 10. So 10, sorry, here VB is how much? 15. So 15 by 10, that should be 1.5 ampere. Similarly here VB is 15 minus VC is what? Minus 26.25. So minus 26.25 divided by 15. So here it will come 2.25 amperes. Then VC by 10. VC is minus 26.25 divided by 10. So here it will come minus 2.625 amperes. Similarly here VC plus 18. VC just check it, minus 26.25 plus 18 divided by 10. So it will come 5.375 amperes I5. So this is what, here we have the I1, I2, I3 and I4. So for this one it will carry for 10 marks or 5 marks. Okay. So here we will see the nodal analysis. So in this lecture what we will see, we have to see how to apply the nodal analysis, steps to solve the problem of nodal analysis, and how to find out the value of I1, I2, I3 and I5 using a nodal analysis. Okay. Now I will give you one more example and some hints to solve the problems. This is a simpler method to find out the answer using a nodal analysis. So nodal analysis, it is a simpler one and simplest method to solve the problems. Okay. So for this one again I will give one more problems and I will write down the equations. Now this is a problems. Okay. So for this, here it is a 15 ohm. Now we have to apply the steps. So in this particular steps, sorry, so firstly just check the how many nodes. So here first node and here second node. So for this one I will mention V1, for this I will mention V2. Okay. Now mark the direction of current. So here it will come plus to minus, current is flowing from plus to minus. I will write down I1. For this I will mark this as I2. For this I will mark this one as I3. Then here it will come, so I4 and I5. Okay. Now this is a ground node. I have to apply the KVL for node first. Okay. Apply KVL for node first. So for this V1 I have to apply the KVL. Okay. So just check how many currents are entering. So only one current is entering, that is I1, and two currents are leaving, I2 and I3. I2 plus I3. Okay. So I1, just check it, starting voltage is how much? 15 minus end voltage is V1 divided by 1 equal to I2. I2 starting voltage V1, end voltage is 0 divided by 1 plus I3. I3, just check it, V1 minus V2 divided by 0.5. Okay. So just do the cross multiplication. You will get, here I will not solve each and everything. 4VB minus 2VC equal to 15. So this is the first equation. So here you will write down 4VB minus 2VC equal to 15. Now I will go for the seconds. Apply KVL for node seconds. Okay. So applying the KVL for node second. Just check it. Entering current is 2 entering current, I3 plus I5 equal to what? I4. I3 starting voltage V2 divided by 2 plus I5 is what? I5, just check it, starting voltage is 20 divided by end voltage is V2 divided by this value is again 1 equal to I4 V2 by 2. Okay, just do the cross multiplication, you will get 4VB minus 7VC equal to minus 40. Okay, this is second equation. So 4VB minus 7VC equal to minus 14. So just subtract it, this will cancel, you will get, is just minus minus here plus 5VC equal to this one. So after subtract second from 1, you will get VC equal to 11 volts and VB equal to what? 9.25 volts. Okay, you just solve it. Previously I have to solve it, then you will find out the value of I1, I2, I3, I4 and I5 and just put the values in the Google Classroom. Okay, so this will be assigned as a homework. Okay, thank you.